Hello friends, we are continuing the plane table surveying. The third method is method of traversing. The traversing means traveling from one point to another point. We have discussed about in the compass surveying itself, right? So similarly here the traversing made by the plane table, it may be closed or open traverse. Predominantly we discussed about the closed traverse, right? In this method, traverse station are first selected. The stations are plotted by method of radiation by taking backside on preceding station and a foresight to the following station. Here distance are generally measured by tachometric principles. Since it can be done for a huge area, the tachometric principles will be applied. What is this tachometric principle? We will discuss in the fourth unit of surveying, right? How the distance will be measured. And surveying work has to be performed with great care since we require the accuracy, right? Suppose A, B, C, D are the traverse station. Here we have selected 4 station. It may go beyond the 4 station also, 5 station, 6 station, whatever the thing, right? The table is set up at the station A. A suitable point small a is selected on the sheet in such a way that the whole area may be plotted in the sheet. The selecting of the A in the drawing sheet is the first key point. If you select it centrally, the remaining point B, C or D, it goes away from the sheet means wasted. We have to do it again. So select the point such a way that the entire area can be plotted in the sheet. So the table is centered, level and clamped. The north line is marked with the help of a trough compass at the top right hand corner of the sheet. With the holiday touching point A in the sheet, the ranging rod at B in the ground is bisected and a ray is drawn. The distance AB is measured and plotted to a suitable scale. Similarly, here the picture shows. This is the first position of the table where it is centered and leveled clamped at A. Towards the ranging rod at B, it was sighted and the line was drawn with the measured distance to a proper scale in the sheet. Next, from here itself we can view the D also. We can draw the line by sighting the D and with the measured distance, so the same scale has to be applied here. We can draw that also. If not, we can complete from there at the other end. Next, the instrument is shifted to the station B. It has to be centered over the B, leveled over the B and clamped properly, and the orientation has to be done by back sighting towards the station A by holding the alidate along the line BA, right, and sighting towards the table has to be rotated and it has to be clamped properly. Then by keeping the alidate at the point B, small b, and sighting the capital C, that is a ranging rod at C, draw a line with the measured distance BC to a proper scale. Then shift the instrument to the station C. The same procedure has to be added up. Backside the B, draw the line towards CD. If you have already drawn the line here, it will get closed. If not, there is an error. To make the check from C to A, make a sight and drop a dotted line, right? It has to go through the A. Similarly, if you shift to the instrument to the D and backside the C and orient the table, if you see by keeping the alidate at D and sight the B station, if it crosses exactly the small b in the sheet, then the traverse is get completed, right? This is the procedure explained here. You can pause it and read the same thing. The check lines, and if there is a error of closure, the traverse is not get closed, Otherwise, the amount by which the plotted position of the first station on the faucet fails to the close is designated as the error of closure. It is adjusted graphically if the error is within the limit. If not, the surveying has to be repeated. You try to see this animation. Station small table is kept over P and marked as small p with the measured distance PQ is plotted, and towards S also it is oriented. Draw the shift the instrument at Q, backside, view the R, drop the line, mark the line, shift the R, side the S, the check line, then shift the instrument to the S, another check line. If it exactly crosses all the things, then the traverse is complete, right? This is the process of method of traversing. Next is the method of resection. Resection is the process of determining the plotted position of the station occupied by the plane table. Where we are keeping the plane table in the ground, that position has to be find out in the given map. That is the process of method of resection. By means of how? By means of sites taken towards known points, location of which have been plotted. So here there are four methods: by compass, by backsighting, by 2-point problem, by 3-point problem, right? We will see one by one. Suppose it is required to establish a station at position P. Let us select 2 points A and B on the ground. Most probably we choose 2 points, right? The distance AB is measured and plotted to any suitable scale. The line AB is known as the baseline. You can go through this procedure. I try to explain the same with the diagram, right? The instrument is set up at the A, right? So it's properly center leveled, everything over the station A, and small a is plotted, and the B also the known point, the measured distance, it can be plotted, right? From the station P, we have plotted as P1. Keep the early date, the same procedure I try to explain with that. The table is set up at A, it is level centered, okay. By bisecting the ranging rod at B, the table is then clamped. With the early date touching point A, the ranging rod at the P, the station required, is bisected and a ray is drawn. Then a point P1 is marked on this way by just eye judgment, right? We don't know the distance from A to P1, so just by eye judgment we plot the P1, we mark here, right? Next, the table is shifted and centered in such a way that P1 is just over the P. The point required, we try to place the table over that point. It is then oriented by backsighting the ranging rod at A, right? With the early date touching the point B, the ranging rod at B is bisected and a ray is drawn. Suppose this ray intersect the previous ray at the point P. This point is the required point. It can be transferred to the ground by using the U-fork and the plumb bob, right? So already we have drawn this ray, it is already available, the AP1. We have centered approximately over the point B. We kept the validate over here and side the B and drop the line. If it meets here, that is the point, and it has to be transferred to the ground. This is the first method, right, in the method of resection. This method is used only for small scale or rough mapping, right? By compass, how we can set. Let A and B be two visible stations which have been plotted on the sheet as small a and b. Let C be the instrument station to be located, to be determined also. Set the table at C and orient it with compass. Clamp the table. Oriented compass means the north was plotted at the top right corner, right? Pivoting the alidade about A, draw a ray towards A. As similarly, pivot the alidade about B, draw a ray towards B as BB dash. The intersection of AA dash and BB dash will be give the point C on the paper. It is very simple but very rough. Just the instrument is at A, side the A, draw a line and extend towards the, that is A dash. Similarly, you try to draw the ray by bisecting the station B and extend it. If it meets at the point, it is the required point, since we have oriented towards the north already. So this north can be plotted here at the top right corner predominantly. If it is any congestion, we can have it here also, no issue, right? So the C point can be, so it is a very rough method. Next is the 2-point problem. In this problem, two well-defined points whose position have already been plotted on the plan. So with the plan only we are going to determine the third point. So the plan will be already drawn plan, or map will be the drawing sheet for these things. Then by perfectly bisecting these points, a new station is established as the required position. How we can see? Suppose P and Q are the two well-defined points whose position are plotted on the map as P and Q, small letter. It is required to locate a new station at A by perfectly bisecting P and Q. An auxiliary station, means supporting station B, is selected at a suitable position. The table is set up at that point B and leveled and oriented by I estimation. That is approximately the table, the map is parallel to the ground station PQ, right? Approximately by I, it is clamped. When the alidade touching P and Q, the points P and Q are bisected and rays are drawn. Suppose these rays intersect at B. Right? We are already settled over this B only auxiliary point. These are the rays, right? These are the ground station, and which was available in the map. This is ground station. This was the point available, the same point on the map. So drop the line, it meets the B. We have obtained the point B, right? With the alidade center on B, the ranging rod at A is bisected and rays is drawn. Then by I estimation, a point A1 is marked on this ray, right? The table is shifted and center on A with A1 just over A. It is leveled and oriented by backsighting. With the alidade touching P, the point P is bisected and a ray is drawn. Suppose this ray intersects the line BA1 at a point A1 as was assumed. So then we shifted the instrument and it kept over the A, right? So from here it was shifted here. From here we adopted the procedure explained, and you obtain such a degree, such a rays, that the point A1 can be established. If not, the point R is established. How it is established, we will see. With the alidade center on A1, the point Q is bisected and a ray is drawn. Suppose this ray intersects the ray BQ at the point Q1. The triangle PQ1 is the triangle of error and it has to be eliminated. For that, the alidade is placed along the line PQ1 and a ranging rod R is fixed at some distance from the table. Then the alidade is placed along the line PQ and the table is turned to bisect R. At this position, the table is perfectly oriented. Finally, with the alidade center on P and Q, the points P and A are bisected and the rays are drawn. Suppose these rays intersect at point A. This would be the exact position of the ground station A. This can be marked on the ground by using U-fork and plumb bob. Right. And the last method is the 3-point problem. This 3-point problem again can be done by 3 methodology: Bessel's method, mechanical method, trial and error method. 3 well-defined points are selected. Here we required 3 point, in 2-point problem 2 point. Have already been plotted on the map. Then by perfectly bisecting these 3 well-defined points, a new station is established. No auxiliary station is required in order to solve this problem. This table is directly placed on the required position. Right, you will see the one by one. This is the graphical or the Bessel's method, most accurate method. Suppose capital A, B, C are the 3 well-defined points which was plotted in the map as small ABC. Now it is required to locate a station at P. The table is placed at the required station P, where I need to determine approximately if the point ABC in the ground is in such a way. I am setting my instrument parallel to those 3 points approximately, and I try to confirm that my position will be the B. Right, the table is clamped. The alidade is placed. You have to remember the notations carefully in this method. Alidade is placed along the line CA and the point A is bisected. Right, the table is clamped with the alidade in center on C. The point B is bisected and the rays are drawn. How? CA, it is the table is oriented towards CA by bisecting the A. Then keep the alidade over C and view the B. A ray is dropped. Right. Next, the same procedure with respect to AC will be followed. Previously we done with CA. Now we are going to do with respect to AC. See the procedure. Again the alidade is placed along the line AC and the point C is bisected and the table is clamped. With the alidade touching A, the point B is bisected and a ray is drawn. Suppose this ray intersects the previous ray at the point D. At the point D, the alidade is placed along DB and the point B is bisected by rotating the table. At this position, the table is said to be perfectly oriented. Now the rays AB, BB and CC are drawn. These rays must be met at the point P, which is the required station. Most probably we get the exact position in the first attempt itself. This is most accurate. If not, we have to repeat the procedure again. Right, this is the Bessel's method or the graphical method. Next is the mechanical method. Why it is mechanical? We are going to use a tracing paper. With respect to that, we determine the position and we shift that to the actual map. Right, the same thing. A, B, C are the 3 well-defined points which have been plotted on the map as A, B and C. The table is placed at P and leveled. A tracing paper is fixed on the map and a point P is marked on it. Approximately we mark the point. With the alidade centered on P, the points A, B and C are bisected and rays were drawn. All the rays. These rays are not passed through the point small b, A, B, C in the map, as the orientation is done approximately. It may be happened rightly in the first attempt, very rarely, right? So these points are all the points available on the map. I have set up my instrument at P. I don't know whether it's right or wrong. I kept the alidate on the point P, and site A drop a line, site B drop a line, site C drop a line. It may cross over the B, A, B, C, or may not. Mostly not. So all the lines have drawn over the tracing paper only, right? Remember that point, tracing paper. Now such a map was obtained. Try to unclamp the tracing paper and rotate in such a way that these lines exactly touches the point ABC over the actual map. Kept the tracing paper and mark the P by pricking using a pin over the tracing paper inside the drawing sheet. So there will be a mark will be created in the sheet. Right, now we can remove the tracing paper. With the help of that pricking point marked as the P, and side the A drop a line, side the B drop the line, size drop the line, you will get the exact position, right? This is the mechanical method. The same procedure is explained here. And next is the last method, is the trial and error method. We have already discussed about the formation of triangle of error. That will happen here also. You please listen, read the procedure here. I will try to explain with the known ABC points are available on the map. It was placed over the table. I required the point P, right? So these are the ground station which is similar to the ABC. I kept the point. Keep the alidate on the A, site A, drop a ray. Similarly over B, drop a ray. Similarly over C, drop a. If they meet exactly at common point, there is no error. If not, it will create a small triangle of error. So this has to be eliminated. This triangle may be big or very small. So if it is big, our position is too wrong, we have to move from that. Here also, if the triangle of error is such a way that you have to either move this way or this way, and repeat the same procedure till the triangle of error get closed. The only way is trial and error, right? The same procedure is explained. And what are the points to be kept in the mind while doing the plane tabling, right? All the ground station should be marked as the capital letters, and the same points marked in the sheet or the map or in the paper will be in small letter. This has to be kept in the mind. The rays from survey station to the object shall be drawn by dashed lines, dotted lines, dashed. The alidate should be properly pivoted while sighting the object, right? These are the things has to be followed, right? Ground stations are capital. This is the table over the map. All the letters will be in small. The rays which we are dropping, we have to draw like dashed, and the alidate should be properly pivoted over the stations, right? The first survey station and the scale of the map shall be chosen that the entire area can be plotted on the paper. While establishing magnetic north on the paper using trough compass, things causing local attraction shall be kept away of the table. The plane table should be clamped after centering and leveling. The table should be rotated at the time of orientation only. Meanwhile, it should not be rotated. What are the error may occur based on the instrument? Error in manipulation sighting, error in plotting. What are the instrumental errors? The surface of the drawing board is not plane. The edges of alidate is not straight. The object vane and side vane are not exactly perpendicular to the alidate. The edge of the alidate are not parallel to the line of sight. The fixing clamp is not proper. These are the instrumental error may happen. This has to be taken care before starting the survey. Error in manipulation and sighting, that is defective leveling, improper sighting, improper orientation, improper centering, movement of board between sights improperly. These are the manipulation and sighting errors. Errors in plotting, defective scale of map, choosing the wrong scale, right? Wrongly intersecting the rays drawn from two different stations, right? We mistakenly doing. These are the errors may cause. So the questions for your remembrance and understanding, you have to try to answer these questions so that you can answer anything. For the plain table portion, mostly theoretical portion only will be asked. So these questions you try to remember and try to answer, right? Thank you, friends.